Hello there. It's been a very long week in terms of hours and fabulous things being delivered by many of the elements of the team. Um, so what I would say was really important was to, as I believe, okay, a bit of messing up with the streaming software around here. But let me go to what's out there. Um, Essentially, I'd say in the last in the last 5 months, we've been working, really hard, really wonderful to build the moon rover. In this case, the one from Planetoid, Planetoid Mines. Um, you will you will be able to confirming in here that we've got. Because I wanted to show some of the things, like really cool. One is out. Some of this thing out of here. And yeah, we are definitely on air. Okay. And it's already being epic. Um, so what's been the key thing for this moon system? Man, first of all, we already had a solution. Okay, we already had what's called a technical architecture. It means a thing. Okay, we already had a moon rover from Kevin DuPriest, and as the team evolved, the thinking it moved from something that was, I would say, lightweight and but workable or working to something that is extremely powerful, much more confirming in here that this stuff is working. Something that is definitely much more robust, heavily robust, um, capable of. Okay, so catching up the phrase so that you guys have time and you can put comments. Our moon rover is a blast. Okay, but how do we do the systems architecture? How do we pick up these things of what is a system, what is the architecture? I think there are two fundamentals, three fundamentals. What are the requirements? What is the thing that we need to deliver? In this case, the list of requirements is long, but it's not. It's possible to manage. That is, we know that it needs to operate in the conditions of the moon for minus 20 to minus 120 degrees Celsius to 100 degrees Celsius. Okay, so if you expand 30% more on that, you have a good coverage. So something that operates continuously up there. Hard stuff, eh? Because many materials have properties by their own constitution elements that make them um, brittle, or they make them conductive, or they make them just change properties from what you have. And this temperature gradient also has problems with electron charging effects. So electrons move effectively from one side to another, and then the surface of the moon could also be at a very different temperature for something that is catching sun. That one needs definitely work. But okay, it's a requirement, correct? It has a thermal gradient from here to here. Needs to operate on the moon. Needs to operate on the moon, and then we describe the conditions of operation. Man, but I would say that one of the hardest things was, and I've seen this in all other space companies. It's although we have a system, when you start making changes, we need to definitely agree on the BOM. That's the bill of materials. Or if you want to think about this in initial concept design, that has an initial BOM. That is, what are the things that constitute the system? Really important. And then what does the system do? Okay, so in this case, look, I think you've seen the pictures in here, and that the excavator is able to pull up regolith in these directions. Then it maintains them on the drums, and then, well, I cannot speak much more, but it does these. Okay, these are the functions. Okay, so it excavates, or in our case, it needs to exhaust enough newtons to put some cargo somewhere. That part was, when you start conveying the things, the pieces of the system with what it needs to do, and I hope this is making sense. Pieces of the system are, if I'm drinking coffee, it could be this, and if I had a plate, this is the plate and coffee. And what does it do? Well, it sustains the cup, and then I should be able to drink from it. The cup needs to be protecting me from temperature. It's open on the top, and it needs to be able to carry from one side to another. Okay, so that's functional architecture, the things that are done. And then what will anyone ask is, how do you know that this thing is working? So that's where testing comes along. Okay, so we've got the requirements, functional architecture, physical architecture, the things. Okay, the cup, the plate, the cuchara to move things around. And what does it do? In this case, it holds coffee during X amount of minutes at the temperature of this, and whatever. And it essentially doesn't burn the person. Okay, so that's how you handle most of the starting to think about those requirements. I would say that as we changed the architecture, it also was fun to see what are all the implications, because then all systems are connected. Yeah. So there is no such thing as only independent work. There could be, but essentially, if you change the weight of some of the materials in here, you need more energy, okay, to make them move. How do we do systems engineering with a smaller team? I would say you don't worry that much with the names of the gateways. You worry on thinking on one, locking down a design. That's important. Really saying, okay, this is design. Let's go with these, okay? And then locking the main, understanding for the main parts, the mass. Okay, so we need to have a mass estimate. It's really important. And then understanding what are the energy requirements. Okay, that's cool. And then understanding how we're going to test each of the parts and how we're going to test the interactions. That is, how do we know that the coffee is good after X amount of minutes? And I would say that that's barely enough to get started. Okay, to get started with a project that has a head and shoulders and arms and heart and legs, and it can walk and it can run. Okay, it can do things. So it's been extremely fun, extremely hard as well. I'm back into Norway for other types of work. But I wanted to give a catch up on the feedback on how this adventure into the systems engineering and into the process side has been going on, as I throttle the world for more knowledge and essentially to apply and to grow in the realms of space. To enjoy. If you do have questions, I'm launching a set of new courses on dust mitigation, on design of systems, also on systems engineering, that I think will be helpful for any team. I've been fascinated with the way that requirements are managed, fascinated with the way that organizations either use process or don't. Very, very interesting. Or these big layers of process and things. How can we take them out? This was an excellent second turn for the NASA Epic Challenge. to give more depth into what processes are needed, and just more more application of how are we going how to do things. So that's been really interesting. Okay, reach out if you want to know more about the moon, if you want to know more about requirements management, functional architecture, physical architecture, and how do we bring this into the organization, into the place that you are working at. Tooling wise, yeah, there are tools out there that are really good. It's true, but there are things like out there that can help on the requirements management of these. But if you can have one person in charge of a certain thing with a team of people that work with him, and another one, for example, someone is in charge with the functional architecture and physical architecture and works with the folks that do the design and the test in an integrated team, a team that does this end to end. That's perfect. It's a great way into Scrum or into what Joe Justice has shown that is really helpful both for Tesla, SpaceX, Amazon, many companies that utilize Scrum, the Scrum methodology. The moon is hard, but we'll get there. Okay, just enjoy and speak soon. Any questions, just drop in the lines below.